a promise. I won't quit, keep going till I got it. I won't give up till I'm on top.
Yo, no, I ain't the type to give up. If I do something, man, I do it till I get what I want. I turn a business out of nothing into something I love. I got a poker face, but honestly, I'm not one to bluff. I flip a switch, never miss, man, I always stay up. Don't let them see you, bitch, always have a plan to stay tough. This life ahead of you ain't easy, it was built to be rough. But that's what makes a personality, is tragedy, bruh. So keep your head on your shoulders. Now we ain't out here moving rocks, we out here moving boulders. Now we ain't getting posterized, we out here making posters. And we ain't got nothing to hide, we move forward like soldiers. You better wake up for the pay stub, or you'll pay up. Don't make love to the game, bruh, fuck the game up. Change up, rearrange stuff to your greatness. Famous for the way up, play the game, bruh.
Never stop, I'll get it if I want it. Gotta make to myself a promise. I won't quit, keep going till I got it. I won't give up till I'm on top, yeah.
You know I'm always honest, there ain't no way I'm ever stopping.
I won't quit, keep going till I got it. I won't give up till I'm...
Hello everyone, this is Carmelo Manuel, CEO at NÖRGRU Group, a company of inventors and 3D designers. And in today's video, I would like to show you something very special. Alright? So basically, I have the intention to recreate in scale 1:1 the full topography of planet Earth, right? Like everything. The bathymetry. So basically, the seabed of the ocean. The 30 meters resolution of the the surface landscape of the entire planet. And you might think, oh my god, this is insanity, like, are you sure you're gonna be able to do that? Well, yes, yes, it's possible. However, it's complicated, of course. My first approach obviously requires some satellite imagery, as you can see right now, and here on the JAXA, Japanese Space Agency website. Here, basically, they allow you to download completely for free. Of course, you need an account, you need to register, but they allow you to download for free a 30 meters DSM data map, basically a global digital surface of the Earth, of our planet, and there are several tiles here. I'm not gonna count them right now, but there are like several, there are many. So the first process is, before this, the first real process is to download the JABCO. As you can see here, the website, you need to download the JABCO global bathymetry data, gridded bathymetry data, this one. So yeah, if you download this one, you're gonna it takes a lot of space. It's like 8 gigabytes, even more maybe. And now they released even the JABCO to 2025. Let me see. Let me check a second, because maybe I'm using the old one, the 2024 maybe. Let me check. Maybe. I have so much stuff here going on. Too much stuff. See, I made a folder, a very specific folder. Yeah, I'm using the 2024 grade, which crap, it's a mistake, because they just released the 2025, so, or I guess I'll have to download everything once again, but it's fine, it's okay. So basically, as you can see here on this website, thanks to JABCO, you'll be able to see to get a topography map of the seabed surface, and to me this is extremely important, because usually when you're dealing with some some terrain, some digital terrain, either in video games or whatever, you never get to see the seabed, like never. That it's either fake or you don't get the real thing. So the way to get the real thing is thanks to JEPCO, because they're doing an amazing job. If you can, please support them. Like they're literally every year they're scanning more and more the the seabed surface and topography, the geology of our planet. So they really, like, shout out to them. They really deserve a lot of praise, and this information is extremely useful, because if your objective, like mine, is to recreate planet Earth, digitally speaking, you need this sort of data. So here in QGIS, this program that is also free, completely open source, and here I basically made a 30 degrees grid, in which like 72 tiles in total, if they're 30 degrees each, or instead they're like 8 tiles. I can tell you the degrees now, but like I made several versions. All right, this is the 8 tiles. There are 8 tiles here of JEPCO, and then you have the 72 tiles that are much smaller, easier to work with. All right, so the whole process is I need JEPCO first. I need the seabed topography. Then after that I'm gonna need the JAXA. All right, so we go back to this website. I'm downloading everything, by the way. I can assure you I'm gonna download everything, and I even made this basically this HTML web page, all right, with some CSS and a bit of maybe JavaScript. I made this because so I can keep track on what tiles I've downloaded. As you can see, I've downloaded this. You can click, you can check and uncheck to see what you've downloaded, what you still have to download. And as you can notice, there's a huge amount of stuff that I still have to download, like a massive amount of stuff. All right, these are maybe 100 gigabytes in total. I have no idea, but it's worth the sacrifice because the end result is gonna be absolutely amazing. And okay, I'm not gonna open here the TerraGen program. All right, I'm not gonna do that right now, but I'm gonna show you the renders. All right, the renders. This clearly is not the end result. All right, but you can already see, you can already guess what the end result will look like, but it's gonna be even better than this. So it's absolutely stunning. It's amazing. All right, it's worth doing this, in my opinion, because like to me it's a huge waste of time to all the time open Gaia or TerraGen or whatever, World Machine, World Creator, whatever program to specifically make a map, create a terrain. Every single time I need a terrain for Unreal Engine. Like, no. All right, I love standardization. To me, it's much better to create the whole planet, have everything set in place, everything is, makes sense. All right, everything is very aligned with one another. Everything is subdivided in tiles, in a grid, so to speak. To me, this approach is 1,000 times better. All right, maybe someone might disagree, but that's my opinion. So to me, it's absolutely essential to get the whole planet in one place, get the whole planet working. And the only program that is capable of achieving this, as far as I can tell, is Terragen. All right, I'm not gonna start it right now, but all right, it's a program that you can find. Okay, I'm gonna just show you. Okay, Terragen 4. All right, that's the program. And it's a very powerful program, indeed. You know, this is not fake. All right, you can literally go from space down to the surface level of the planet. All right, so it's insane, it's crazy, it's amazing. And you know, as you can see, I did many tests, you know, to figure things out. There's still a lot of work to do, but I'm very proud of my results so far. You know, like this is pretty cool. All right, it's very freaking cool. So I'm also using this program. It's called VT Builder. All right, and you might ask, okay, what's the point of this program? First of all, you can open, you can import rasters GIS data in here. All right, elevation models. All right, like for example, let me see if it, yeah, because it's too big, you know, this is an old program, unfortunately, but I managed to import this tile here. As you can see, it's Antarctica, a bit of the Jebco tile, and like it's useful because, you know, the main reason why, in my opinion, this program is useful is because you can check the height, you know, minimum height, maximum elevation of the terrain, maximum height. Also, you can do some math to figure out the dimensions of the, you know, of the tile. It you know, has its use. Also, you can do other cool stuff here. And now we can figure things out in Gaia. You know, Gaia it's another program in which I can import each tile. All right. And by importing each single tile that I'm exporting from QGIS, so from here, I know I might be, someone might think that I'm talking alien stuff, or but it's very simple. You know, this is a tile. As you can see, I'm gonna check and uncheck all the time. This is a tile, right? I've exported this tile. All right. So wait, give me a second. I've exported this tile and imported it into Gaia, another program. Why? Because here I can, of course, right now it's not accurate. All right, I have to do some math, have to do some complicated stuff, but you know, here you could arguably clamp the terrain. Let me zoom out. All right, okay. So this is the coast of Africa. All right, it's not that tile that you saw before. This is another tile, but this is the coast of Africa. All right, the seabed topography underneath Africa. All right, so we're talking about the Atlantic Ocean. All right, so this here, as you can see, is the Atlantic, the seabed surface of the Atlantic Ocean. Here is the coast of Africa, all right, the west coast of Africa, and the dimensions are not correct right now. I'm gonna ask AI. I'm gonna be honest with you, I have no idea how to do the math. I'm gonna ask AI how to do it, how to figure things out, right? Maybe there's another way here. I don't know, you know. We'll see. But the point is, why am I using Gaia? Well, because here, you know, as you can see, there's an erosion node. If I delete an erosion this node, you know, what happens is that you start to get a lot of these. I don't know if you can notice them, if you can see them, but you get a lot of these, like, how can I call them, you know, these flattened surfaces, you know, cravings on the floor. I don't know how to define it. Like, you get a lot of these artifacts, you know, a lot of this stuff here. And why this stuff exists in the first place? Well, because the JABCO raster topographical data, unfortunately, is not. But it also makes sense, you know, if you really think about, you know, it's not super high definition, all right, and it makes sense. It does, because if it were extremely high resolution, it will take thousands of pixels, you know, it will be a huge, massive image, like no computer will be able to compute it in real time. So, at least not right now. So, or at the very least, my computer, despite being extremely powerful, but it will struggle, you know, it might run out of RAM, or even though it has 64 gigabytes of RAM, but it might, you know, you can, you know, all right. So the picture of JABCO has to be, you know, reasonably large, right? Not too much. I can even show you here right now. See, if we go to this folder, all right, I myself made, I prefer using sub-ICE topography. So I myself, you know, you download as a zip file, see, and then what you get basically, see, this image alone is 21,600 pixels, right, squared, and it's almost 1 gigabyte big. Like, can you imagine that? It's a 1 gigabyte sized picture, right? It's massive already, and even then, it's not super high resolution, all right? So it's completely understandable why it's not. You know, like, I have nothing against JABCO decision on this, because it makes sense. So basically, I combined all of this, right? I merged. The approach that I use is that I merged. I give it some time to load. See, it's struggling, right? So I merged 2 pictures, then I merged 4, and then 8 in total, and 8 in total is a 3.42 gigabyte sized picture, alright? So it's a huge, massive picture. See, it's not even capable of opening, but, and it's almost 1,000 pixels squared, almost, basically, you know. You can see here from the thumbnail, I'm gonna make it a bit bigger, but you can see, alright? So that's the entire JABCO picture combined, and the thing is, QGIS can open that picture, all right? And once it opens, is this one, as you can see, right? It's this one. So my idea is, I get JABCO, I then overlay, all right? I start placing JAXA, you know, the Japanese Space Agency, 30 meters of elevation data. As you can notice here, you can see it's very detailed, you know, it's very, very detailed. See, you can notice how detailed this stuff is. So my plan is, I'm gonna overlay everything on top of JABCO, so I maintain the seabed, and I also have the, you know, the topographical surface of the planet, all combined in one. And then when everything will be finally complete, I'm gonna need textures, of course, you know, but as a reference. So let's be clear about this. I'm gonna use satellite imageries, right? So Bing Maps, you can create your own custom X, Y, Z tiles. So Bing Map ESRI, whatever, this company is very well known. World imagery, right? As you can see, I'm turning on and off. All right. This SRI World. I'm Italian. I'm sorry. SRI World Imagery, right? You can remove it. You can, and then this one is Bing Maps, right? It's Bing Aerial. On and off right now. On now, and then you have also Google Satellite. All right. And then ASR again, and others. You can also, add more stuff. And the way you add, you come here to XYZ tiles, and you create a new connection. All right. So there's I can show you. For example, here in Edit Connection, you take this link, from the internet. There is a specific website for this stuff, and then you just create a new connection, paste the link here. All right, paste it, whatever. Paste the link and add a name, and that's it, and it works. All right. There's also a plugin that you can download. I can't recall the name of that plugin for QGIS. I don't know, but I don't use that plugin anymore. Like this approach is very simple. It works, and that's it. So the next step is I'm gonna. Let me bring the grid here once again. So I'm gonna basically either make a smaller grid here, because yes, it's completely possible. And let me show you how. I come here, I clip, all right. I create this grid here, and this clip. Let me show you this clipped rectangle box, whatever, and then I can, for example, I can create a grid, all right? I can create a grid using that rectangle, the clipped one, as a boundary. So I'm gonna create rectangles. I'm gonna set a 10 degrees, so it's not super small, 10 degrees, and everything's perfect, and it just works. So this is 10 degrees, all right. Let me come here to where it is. Yeah, okay. So this is a 10 degree grid of the 30 degrees grid of before, the tile that we had before. Wait a second. You can, for example, put overlay. Wait, no, still nothing. Yeah, because it's not feature, is this one. Yeah, all right. So 10 degrees, all right. I'm gonna figure out a way, but essentially the plan is I'm gonna download some these satellite images, right? And then there are several ways to achieve this. Let me check here. Let me check Power Toys. I forgot the shortcut. All right, I forgot. So I'm using a tool called Power Toys for Windows, and you can, for example, where is it? Yeah, it's in Italian, but I'm gonna find it. Okay, color selection. So Windows key, Shift and C. All right, Windows key, Shift and C. Do you see this? Do you see? All right, now I can color pick. All right, the colors on the screen. And what's the point of this? The point is, in the right programs, it's going to be possible to create so-called splat maps. All right, so I take the colors, the overall colors, and then basically I'm going to create an image in which all these farm fields, all this stuff, the sand, everything will be defined by specific colors, all right, the colors that you can see now, all right. Wait, okay, yeah, like for example for this color for the sand, all right, I can pick this one, and then I'm gonna tell the splat map, which is an image composed of RGB channels, basically, every channel, like the red channel will be for the sand, for example, the blue RGB, the green channel will be for the farm field, the blue channel will be for, I don't know, something else, another type of farm field, that's something that can be done. It's gonna be complicated, all right, very complicated, but it can be done. And once all of that is done, all right, you're gonna have stunning results inside your Unreal Engine 5. Now, is it possible to import everything inside Unreal Engine 5? No, at least not right now. Right now, Unreal Engine 5 is not able to compute an entire planet, at least not right now. Right, there's a promising voxel plugin 2.0 that is coming this year or next year. It's very promising because they made a video about a showcase, in which they managed to compute the entire surface of Mars inside Unreal Engine 5. So I'm hoping for that program to come out, to that plugin, And here in coming back to Gaia, as you can notice, the plan is to get rid of those artifacts. We can use erosion, for example. We can use the erosion node. Wait, where is it? Yeah, all right, erosion node. That might help. Of course, might is the big word here, because who knows? You might do something, you might not do anything. It depends. You have to try, you have to test here. I can even use blur if I really want to. Actually it's even better as a slope blur. Here. Right here. So I can get rid of that stuff, because it's extremely annoying. Okay, this one is not doing much. No, it's not doing anything. All right. When it comes to computers, it's all about trying. You need to try all the time. You need to test things. You can be the type of person of, see, now I'm getting rid of that. Now the surface is much smoother. But you really can be the type of person that just gives up. You can't. When it comes to computers, you have to try, and you must keep going until it finally works. You have to. Like, there's no other choice. There's no other chance. You have to. See, now the result is much better, right? It's at least that ugly stuff that was here, the terraces. Yeah, I think that's the correct term. Those ugly terraces are no longer that visible, and then I can add an erosion, right? To further. Okay, this one is not. No, this one is not realistic at all. Yeah, I can't use this one. I can't, because that's not how the seabed looks like, right? Unless somehow I manage to remove these channels, maybe somehow, right? But still, it kind of removed the. Here's the thing: you can do whatever you want, but you have to do it in a way that it maintains the original morphological geography, topographical geography of the terrain. You can do something too dramatic. All right, like this is too much. This is way overkill. It really is. I can maybe try with area mask, maybe. No, maybe. Yeah, I guess it's a bit more accurate now. But still, you know. Well, let me see which, you know. Because it will be kind of good, but I have to remove those, like this sort of reverse, you know, these channels. Yeah, something like this, you know, something like this. It's a bit more acceptable. Let me go back to here. Yeah, but it's taking away a huge amount of detail. That's the problem. So yeah, let me see right now. Yeah, see now it's a bit better. Now really is much better. So it's all about trying, testing, you know, trying to figure things out. You know, see what works, what doesn't. See, now it's a bit better now, because it maintains the overall topography. However, also be aware that if whatever filter you use here in Gaia for each tile, it has to be the same for the other tiles. You know, otherwise it will create a level of incongruency. Like each tile will be too different from one another, and that's a problem, of course. Obviously, that's an issue. You know, the tiles have to they need to match, especially in their borders, because they have to be combined at some point. So they must match with one another. And that's it. You know, I really wanted to show you what the fuck I'm doing. You know, it's complicated stuff that clearly a lot of people might not understand. A lot of people might, you know, think that whatever, I'm wasting my time, or who knows, you know. But I don't pretend others to understand this, alright? Because I see the potential of it, I see the technology, I see how useful this stuff will be, and of course, you know, pay a visit to our website, because we will, once all this hard work will be done, we will offer you high details terrain maps of our planet, of our beautiful, wonderful planet. So you'll be able to easily use them in your video games, in your projects, in your Blender architectural, you know, displays. You know, the possibilities are infinite. So thank you very much for the attention. Thank you for everything, and I see you in the next video, in the next tutorial, in the next showcase. You know, stay tuned, follow our company, and we together, we will create a wonderful future for all of us. Thank you very much. Bye.
Never stop, I'll get it if I want it. Gotta make to myself a promise. I won't quit, keep going till I got it. I won't give up till I'm on top.
Yo,
yeah.
no, I ain't the type to give up. If I do something, man, I do it till I get what I want. I turn a business out of nothing into something I love. I got a poker face, but honestly, I'm not one to bluff. I flip a switch, never miss, man, I always stay up. Don't let them see you, bitch.